From CFC bearing roll number 05G9. Today my topic is natural deduction system, axiomatic system and semantic tableau system. Natural deduction system. NDS is thus called because it mimics the pattern of natural reasoning. The system is based on a set of deductive inference rules, assuming that A1, A2, A3 and so on up to AK, where 1 less than or equal to K less than or equal to N are set of atoms, and alpha J where 1 less than or equal to J less than or equal to M and beta are well-formed formulae. The inference rules may be stated as in the table. A theorem in NDS written as from alpha 1 and so on up to alpha 2 infer beta leads to the interpretation that beta is deduced from a set of hypotheses alpha 1 and so on up to alpha 2 are assumed to be true in the given context. Therefore, the theorem beta is also true in the same context. Thus, we can conclude that beta is consistent. This is the table of NDS rules table introducing end. If A1, A2 and so on up to AN are true, then their conjunction, that is A1 and A2 and AN is also true. Eliminating end. If A1 and A2 and so on up to AN is true, then any AI is true where I is greater than or equal to 1 and less than or equal to N. Introducing OR operator. If any A of I where I is greater than or equal to 1 and less than or equal to N is true, then A1 or A2 or and so on up to AN is also true. Eliminating OR operator. If A1 or A2 or AN and so on up to AN is true, and also A1 implies A and A2 implies A and so on up to AN implies A are true, then A is true. Introducing implies. If from alpha 1 to alpha n infer B is proved, then alpha 1 and alpha 2 and alpha n implies B is also proved. That is, if alpha 1 and alpha 2 and so on up to alpha n are true and beta is true, then only alpha 1 implies beta is true and alpha n implies beta is true. Therefore, alpha 1 and alpha 2 and alpha n, that is, this whole part is true, implies beta. Beta is also true, therefore, this is proved. Eliminating implies. If A1 implies A and A1 are true, then A is also true. This is called modus ponens rule. That is, A1 implies A is true when both A1 and A is true, and if A1 is false, then here A1 is given as true, that is A1 is true, then therefore A is also true. Introducing double implies. If A1 implies A2 and A2 implies A1 are true, then A1 double implies A2 is also true. As A1 double implies A2 is true when A1 implies A2 is true and A2 implies A1 is also true. Eliminating double implies operator. If A1 double implies A2 is true, then it is inverse of the introducing double implies. A1 implies A2 and A2 implies A1 are true, then only A1 double implies A2 is true. Introducing negation. If from A contradiction is proved, then truth of negation A is also proved. If A is proved as false, then negation A is proved as true. Eliminating. If from negation A contradiction is proved, truth from A, that is, if negation A is proved as false, A is proved as true. Let's solve a problem. Here we are taking the as A and B or C. That is, from A and B, we have to infer to A and B or C. Here we are taking the hypothesis as A and B and eliminating the AND operator, we get the A and similarly B. Now introducing OR operator. If any one of the operand is true, the whole statement is true. Therefore, B or C is true. And now we are introducing AND operator between A and B or C. Axiomatic system. It is based on set of 3 axioms and 1 rule of deduction. A forward chaining approach. Axiomatic system is a forward chaining approach. In this, a guess is required in selection of appropriate axiom. In this, only 2 logical operators, not and implication, are allowed to form a formula. Any formula can be written using negation and implies. In axiomatic system, there are 3 axioms which are always true, and one rule is called modus ponens as follows. Axiom 1. A implies B implies A, and axiom 2. A implies B implies C can be they can be written as A implies B implies A implies C, and negation A implies negation B can be written as B implies A. Rule, hypothesis. If A implies B and A, consequent B. Interpretation of modus ponens rules. Given that A implies B and A are hypothesis, B is inferred as a consequent. That is, A is true, and if A is true, A implies B is true only when B is true, and so B is inferred that is true as a consequent. Now let's solve a problem. We have to establish A implies C from A implies B, comma B implies C. Here we are taking the hypothesis as A implies B and hypothesis 2 as B implies C. Now we are applying the instance of axiom 1 on B implies C. That is, axiom 1 is A implies B implies A. Here B implies C acts as A. And modus ponens rule is applied on B implies C and B implies C implies A implies B. That is, this A implies B implies C will be true. Instance of axiom 2 is applied. Instance of axiom 2 is A implies B implies C can be written as A implies B implies A implies C. Similarly, we are writing here. And applying modus ponens rule on 4th and 5th lines, we will get this part as true. A implies B implies A implies C. And applying modus ponens rule on this and this, that is first statement and 6th statement, we get A implies C, and the problem is solved. Semantic tableau system, a backward chaining approach. It is a backward chaining approach. A set of rules are applied systematically on a formula, a set of formulae in order to establish consistency or inconsistency. Semantic tableau is a binary tree constructed by using semantic tableau rules with a formula as a root. These are the semantic tableau rules. Here alpha and beta is true if both alpha and beta are true. Therefore, a tableau for a formula alpha and beta is constructed by adding both alpha and beta to the same path. Rule 2. Negation of alpha and beta. This becomes negation alpha or negation beta. Is true either if negation alpha or negation beta is true. A tableau for a formula negation alpha and beta is constructed by adding 2 new paths, one containing negation alpha and the other containing negation beta. Similarly, alpha or beta is true if either alpha or beta is true. A tableau for formula alpha or beta is constructed by adding 2 new paths, one containing alpha and the other containing beta. Rule 4. Negation of alpha or beta. This becomes negation alpha and negation beta. Is true if both negation alpha and negation beta are true. Therefore, both negation alpha and negation beta are placed in the same path. Rule 5. Negation of negation alpha is true when alpha is true. Therefore, a tableau for negation of negation alpha is constructed by adding alpha on the same path. Alpha implies B is true when either negation alpha or beta is true. Therefore, they are negation alpha is placed in one path and beta is placed in another path. Negation of alpha implies beta is true when either both alpha and negation beta is true. Therefore, alpha and negation beta are placed in the same path. Alpha double implies beta is true when alpha and beta is true or negation alpha and negation beta is true. Therefore, alpha and beta is placed in one path and the negation alpha and negation beta is placed in another half. Negation of alpha double implies beta is true when alpha and negation beta is true or negation alpha and beta is true. Therefore, alpha and negation beta is placed in one path and minus the negation alpha and beta is placed in other part. Let's solve a problem. Construct a semantic table for the formula. This. Here we are using rule 1 and here since we have AND operator, we are placing both A and negation B and negation B implies C in the same path. Here A and negation B, again we are placing the A and negation B in the same path. Here negation B implies C can be written as negation of negation B or C. Therefore, the negation of negation B is placed in one path and C is placed in other part. And negation of negation B can be written as, is considered as B. Here we have closed this path as B and negation B both lie in the same path and both negation B and B cannot be true at the same time. And here C, there we do not have any negation C, therefore this path is open and this path is closed. Thank you.